Welcome, everyone. Welcome. So we're still seeing people drop in, so we'll give it a minute. Thank you all for joining our live webinar today, presented by Rapid Shape, 3D Printing Precision Models, your guide to master the transition from analog to digital. Today, the chat is available, guys. So as you're coming in, feel free to say hi. I'd be super curious to see where everyone is coming from. So if you want to put in the chat where you're tuning in from, I'd love to see it. I think it'd be also really interesting for speakers. Okay, so welcome everyone. Welcome to 3D Printing Precision Models, your guide to master transition from analog to digital. My name is Julia Bar-lev. I am the head of marketing for Rapid Shape, and I'm excited to be your host for this webinar today. We really have a packed agenda today. And for anyone that hasn't been on the previous Rapid Shape webinar, I will provide a brief overview of who we are, what we do at Rapid Shape, and where we actually come from. Just to lay out the plans for today a bit, I will give a brief introduction to our Pro 20 and D50 solution, and then hand over to our wonderful guest speakers today, Jimmy and Kelly Fincher. Jimmy and Kelly are really going to go over the steps on how to achieve precision models, which means they are also covering the design and scanning steps, really honing in on that so that all of you know how to achieve well-printed models there. Jimmy and Kelly are the owners of Cosmetic Advantage Dental Laboratory based in Louisville, Texas. And yeah, let me give a brief introduction to both of them. Jimmy Fincher began his career in the US Air Force, where he built a strong foundation as a dental technician. Then he started a one-man lab in 2009, which now has grown into a team of over 10 skilled technicians. Correct me, by the way, guys, if that's on any of this. And that is Cosmetic Advantage Dental Lab. With over 25 years of experience, Jimmy specializes in restorative work and utilizes digital technologies for the last couple of years to really create more efficiencies in his own team. He's also been teaching nationwide for different companies on the topic of digital technology and how to help other dental technicians and dental offices to implement these workflows and to create more efficiencies, to scale up productivity, and to, also always achieve consistent results with that. Kelly Fincher is originally a registered nurse, and she joined Jimmy to help expand Cosmetic Advantage Dental Lab. She was the one who actually initially introduced 3D printing at the dental lab, and she's kind of since then really implemented a bunch of different workflows for the team. As you can see in Kelly's background, I was just mentioning before the webinar, she has a ton of different resins always available at hand, and she's always testing out different things and always kind of looking for the next kind of workflow to implement. Yeah, I'm happy to say that Kelly is today also a colleague of mine at Rapid Shape. She is part of our digital workflow specialist team. This means if you get in contact with Rapid Shape, you're interested in purchasing a printer from us, you can actually book a demo with Kelly or someone else from the team to get started on your 3D printing journey. And also when you then have a printer, Kelly is someone that will be able to help you along the way to really get started. But we'll talk about that a bit more. So thank you so much, Jimmy and Kelly, that both of you are here today. I appreciate your time, and I'm very thankful that you're sharing your skills and knowledge with everyone here. Yeah.
Thanks for having us, Julia.
It's good to have you guys. Okay, before we get started, I do want to mention we have the chat available, so feel free to interact here if you have anything you'd like to add there. Please know that for us, it's great if you use the Q&A tab that's at the bottom. There you can input any questions. It'll help us to keep it kind of organized at the end to address any open questions. Right. Yes, this video, by the way, this webinar is, by the way, recorded. It'll be available at the end on the YouTube channel, the Rapid Shape YouTube channel, and I will share it as well across our social media channels in the next couple of days. So if for any reason you're missing out or you know someone who's missing out and wants to see it, we will make it available. All right, let's get started with Rapid Shape. So this is the beautiful building I'm sitting in right now. We are located in the area of Stuttgart, Germany. This is truly a powered by German engineering company because in the second floor, this is in our entire R&D team is sitting there. They are developing every product that has the Rapid Shape name on it, from our software over our printers, obviously, and our wash and cure solutions. So who are we? We are actually a family-owned company here based in the south of Germany. We are surrounded by other high-tech manufacturing companies in the area. So we fit in quite well in what is a more rural area, actually, with lots of activity, though. In 1983, Georg Schultheiss founded the Georg Schultheiss Electronics, which is still today active as Schultheiss GmbH. Why am I telling you this? Well, this is the company that is actually the background of Rapid Shape. Today, Schultheiss is among the market leaders for casting machines for industrial and jewelry production. I love showing a bit of the older pictures here. This was at the first Schultheiss production facility, just one town over, where the Schultheiss family still lives. In 2011, Georg Schultheiss' son, Andreas Schultheiss, today he is Rapid Shape's founder and also still managing director. He had the task from his father to create the first 3D printer for Rapid Shape. Now, why is that relevant and important? Well, the first 3D printer for Schultheiss was designed to print castable jewelry pieces. And jewelry pieces have to be incredibly fine. They're printed on 25 micron layer thickness, where on the dental spectrum, we usually have, like most applications are printed on a 100 micron layer thickness, where some of them, when we're talking about crown and bridge models, for example, it usually is 50 micron layer thickness. So in 2011 already, we had to deliver 3D printing technology that could have such high precision and print such fine materials. Here's a picture from 2011 with Andreas Schultheiss and the team when they built the first 3D printer for Rapid Shape. Then in 2015, Rapid Shape participated in its first IDS, the International Dental Show, held every 2 years in Cologne. And that's where they presented the first desktop and standalone printers for Rapid Shape. In 2018, the idea of a fully automated system was conceived. And then in 2021, the first RS inline system capable of producing up to 4,000 models per day was actually set up. Now, this is quite the variation from desktop printers all the way up to the standalone printers that are able to fully automate workflows. Today, we are worldwide at your site. We have our HQ here in Germany, Heimsheim, production, support, and part of our administrative team are sitting in Pécs, Hungary. We have support then also in China, in Japan, and in the United States. We have our support team as well as our sales team. All of them are covering this Rapid Shape portfolio. On the left side, you see the desktop equipment. Today, we're talking a little bit about the Pro 20, the wash and the cure, and we're highlighting the D50. If you would like to learn more about the rest of our portfolio, feel free to visit our website or feel free to book a demo with our team to learn about all our solutions. Now, what are we actually trying to achieve as a company? This comes down to our core principles. We really want to focus on user-centric design, meaning every single solution that we come up with, we want to address a real pain point. And I will highlight a couple of ways we have done that with the Pro 20 and the D50, which I will talk about today. Product longevity. Now, this is where Powered by German Engineering really comes in. This is about our glass reservoirs that really outlast almost any other resin reservoirs that I have seen so far. And I think, Kelly, you may agree with me on that one. The build of our equipment is meant to last for a long period of time. We're not building printers that need to be replaced or, yeah, we do. Obviously, there has to be maintenance, but the core principle is product longevity. And we build complete validated solutions that maintain material flexibility. We always partner with the best-in-class materials to create full solutions from our software to the printer, to the wash, the cure. And yeah, that's what we're also highlighting today. We're showing you guys this workflow to really give you an idea of what a validated solution has to be. Now, this is one of our solutions, the Pro 20, the wash and the cure. And I wanted to just give you a bit of background what are these machines about? What are their key points? Now, as you can see, the Pro 20 is a desktop unit. It is a state-of-the-art DLP 3D printer. It has a heated resin chamber, so you really have some flexibility there with different materials that are on the market. When we're talking about ceramic-filled materials, that's quite important. It is an end-to-end workflow, as you see, from the 20, the printer to the wash to cure. You have intelligent connectivity, so they speak to each other. All the settings from the software are transferred to the printer, to the wash, and the cure. It's just a touch of a button then to start each of the jobs. RFID material identification is something I'll show you in a second. And we have, for the Pro 20, over 200 validated materials. So this really gives you maximum versatility and really gives you the option to explore different resins. Now, the Pro 20 has a couple of really cool features why I would like to highlight it now. And one of them is actually the RS Turbo. RS Turbo just means we've done something to this printer to make it really incredibly fast while maintaining precision. The Pro 20 is among the fastest DLP printers in the market, and the RS Turbo is a combination of Rapid Shape patented force feedback technology, which you can see this little silver cell here in the middle of the printer. That's a load cell that helps us constantly measure forces and then reports that force back to the printer to help it adjust the wait times. And that way we are able to the printer is actually able to adjust printing speed within each job. Now we can deliver crown and bridge models printed at 50 micron layer thickness within 15 minutes with that RS Turbo feature. And if you're going at 150 micron layer thickness, for example, ortho models, then you can actually do that in 8 minutes. Yeah, so validated workflows, very important topic to us. Because we actually spend a lot of time and effort. We have a team here dedicated to validation processes with resin manufacturers from around the world. Now, the print parameters are all preset in Print Studio or slicing software. We have the 385 nanometer UV light that produces detailed prints, ensuring color stability. This is something that you may see some struggles with 4 or 5 nanometer LCD printers in comparison. Now, our wash system comes with preset wash cycle parameters and automated wash and dry cycles. So again, all you need to do is come in, click on print job. The last print jobs that were completed on the Pro 20 pop up here. You select the correct one and hit start. That way you can make sure you can delegate actually, and you can always achieve consistent print jobs in the end because you're never switching up any of those parameters. Now, curing is quite important. We have a vacuum cure with a 360 light cure. So really, we truly have LEDs all around. And this is making sure that we have in-depth and consistent results. The vacuum actually improves the mechanical properties of a print job. So this is quite important when we're talking about anything that is meant to last longer in the patient's mouth. Now, just to give you an overview of the resins that are validated, if you want to see more and look in more detail, feel free to go to our website. That's where we have all the resins linked and shown listed by application. Now, I think one of our most exciting and coolest printers we have is actually the D50 because of all the automation features. And I don't want to take away too much time, but I do want to show you this brief video explaining essentially the key features of the D50. And it will relate to Kelly's and Jimmy's presentation later because the D50 is really a high performer for just continuous model printing that can be completely hands-free off. What you saw just now was the automatic resin refill system that constantly pumps resin into the vat. And then here we see the automatic separation module that cleans off the print jobs from the build platform. And what then the printer does on its own is restarting the next print job. So this is a continuous process, and you can actually automate up to 60 print jobs, up to 6 print jobs and a total of 60 models without ever having to touch the printer. Now that comes out to around 3 hours of continuous printing. Yeah, so here just summarizing the feature again, automatic separation module, and then combined with the automatic resin refill really ensures that you can do continuous automated printing without having to interfere with the printer. Now, I just wanted to show this again and say the correct terms here. The D50 lets you queue up to 6 print jobs. The automatic separation module in form of an integrated blade removes the print jobs then, and then up to 60 full arch models can be collected in the integrated basket. This is actually a picture that Kelly sent me recently, and I love it because it shows you this is what you can essentially take out of the printer and walk away with after around 3 to 4 hours. I think for splints it does take a little bit longer, so obviously it depends on what you're printing. Now, because people like to know printing times, I added some here. Please always know that printing times very much depend on layer thickness and the resin that you're using. Not every resin is the same there. Yeah. All right. This was my high-level overview of the Rapid Shape solution here. Now I'm very excited to hand over to our guest speakers today, Jimmy and Kelly Fincher. Thank you so much, guys, for being here. I really appreciate you taking the time, and I look forward to a very informative sessions. Thank you. And there we go. Kelly, you should be able to share now.
Are y'all able to see my screen okay?
Yes, perfect.
Okay, awesome. Well, thanks, Julia, for having Jimmy and I here today. We have really enjoyed our printing journey. It's been a long one. We've been doing it for several years now, but we just kind of wanted to take some time to talk to you guys who may not be printing yet, who may not even be digital in the least, and show you guys our journey, encourage you to change and to try something new. And so let me just introduce us and show you a little bit about us. So, as Julia said, I'm a registered nurse, but I'm married into the industry. And when we opened our lab in '09, I was our first model room technician. And guys, I hated it. I absolutely thought it was the worst job ever. And I think that's where my love for the printing room came out, because when I saw the printers, I'm like, this is what we need. We never need to pour another model again. As you guys all know, that's probably not very realistic, but it definitely sparked my interest, and thus began my journey in 3D printing. I now work full time in dentistry. I have retired from nursing. But a fun fact about myself is I love to celebrate any occasion. This is a fun picture that I threw up here of a Halloween a couple years ago where this employee actually dressed up as me. And guys, I think she nailed it. So I always have a fun time showing some pictures from things that we celebrate. To introduce Jimmy, he is the captain of our ship. He's an Air Force veteran, has been a CDT. He just got his 25-year pin this year. He's been KOLs for multiple large companies. And if you know Jimmy, he loves to be at the bench and loves to be left alone, a luxury he doesn't get very often here in our lab. And he also tolerates me. Here's a picture of one of his birthdays a couple of years ago where we decorated his bench and made him have the dancing men on there all day. So, in talking about change, we thought it would be fun to take you guys down a little bit of the journey of our change within our lab. So, the picture here on the left is a picture of our lab, our very first lab. We were there from 2009 to 2013, and we put together cabinets from Home Depot and made a lab our home in a sense. And then fast forward to from 2013, we moved into the building that we're in today. And this is a picture of what our lab looks like. We're very proud of our lab. We enjoy bringing and hosting in our lab. And we also have master's degrees in IKEA cabinetry. So if you ever want to start a lab and do it with IKEA, Jimmy and I are for hire. We can put together your cabinets in a blink of an eye. Some other things that have evolved over the years is our logo. When we first started, I picked out this @ symbol that I thought looked like a C and an A, and I thought, oh, this is cool. This will be our logo. We laugh at it now. It's quite pathetic. But this is how we began. After we started making a little bit of money, we actually hired a graphics designer who pointed out to us that, hey, did you know Cosmetic Advantage Dental Lab spells CAD? Because we had told him we wanted to be digital, and he made up this design, and we thought it was great. And so we moved forward with it. As the years have gone by, we thought it looked a little tired. And so we did refresh our logo here a few years back. And so here's where we're at today. Very modern, very digital. And all of our labs and our clients, even though we are cosmetic advantaged in the lab, call us CAD. It's a much easier to say than our mouthful of our name, but we enjoy our logo and we think it's fun. Some of the things that we did in our digital journey is one of the first pieces of digital equipment we bought was a scanner in 2009. And some of you guys probably remember where we would scan our models and outsource for copings. And that really was the extent of what we were doing digitally. But in 2010, we brought in a closed system scanner and software and mill. And then we then ventured into an open software and mill. And then in 2016 is when we bought our first 3D printer. And I think we're now in 10 printers later. We actually print more models than we pour, and we're probably 75% digital. We have really seen a huge, huge shift after COVID, where I would say prior to COVID, we were maybe 40-60, and now we're about 75% digital.
All right. Go ahead and click that one. All right, so I'm going to just try and briefly run through a few things. You know, when we're trying to create nice prints and do these jobs, we want to make sure that we have the ability to uh, give us the best, most accurate print that we can. So I'm going to briefly talk about optimizing that print accuracy and then creating some successful STL files. And, you know, the STL files are important because if we don't have a good file that we can feed to the printer, then we really don't, it doesn't really matter how good our printer is. And for me, I'm more attacking this from the design side because yes, it's about printers, but if we don't do the things that we need to do, then it's really not going to matter what we try to print. It's pretty important that we obviously understand the software we're using. In our lab, these are the softwares that I use on a daily basis. Everybody's pretty familiar with Exocad and 3Shape. Zircon's is another kind of a spinoff of Exocad that has some really nice features. And if I'm doing large diagnostics or I want to do some really nice mock-ups, I like using their software for that. And then I deal with Plan Mecca quite a bit just because, A, I teach for them and I have a ton of doctors that use them. And when I'm designing, this is pretty much what my design station looks like. So I try to, oh, can you go back for me? I try to design on 4 screens at once if at all possible. So I usually kind of pull them all up and I'll just have that little box that allows me to jump between all of them so that I can design and just really optimize that speed. But usually this is the way I'm going to try and do it. So, all right. So the two that I'm just going to kind of briefly focus on, and I'm just going to run through a few settings and things like that, that if you're kind of going from milling to printing, or if you're already printing and you're having any frustrations, some of these settings can be influencing whether or not you're getting loose fits, tight fits, and just not getting good prints. All right. So we'll just kind of brush through a few real quick. And I'm going to start with 3Shape because that really is kind of the lion's share of what we're doing. So if you're using 3Shape or if you've seen 3Shape, this is probably a diagram that you've seen. And so when it comes to printing or even milling, these settings are so important because you need to understand when you look at that little menu, the little gray box that pops up when you're generating copings and actually designing your crowns, to know which areas each one of those is going to impact and what that's going to do as far as your fits go and the success of your print. So, you know, you have a cement gap, you have an extra cement gap. And those areas, you know, that cement gap is just a very small amount of space right down near the margin, slightly going up that axial wall. So that's usually where we want to have a tighter gap. And then obviously your distance to margin line. But really important is also going to be just that drill compensation and drill radius. You know, when we were mostly just milling crowns, we had to worry about making sure that we could compensate for that tool path. So that changes with printing. All right, and then this is a screen that everybody who's worked with 3Shape will have seen. And, you know, if any of these are valuable, please go ahead and snapshots or screenshots, or we can figure out how to get them to you. But these are kind of average print settings when I'm actually designing a crown. So, you know, the cement gap for, say, a nano ceramic or any of those sort of materials that I'm making a crown, I'm going to kind of go with these average settings. And these are settings that we kind of dialed in just based on trial and error and screwing up a bunch of crowns. And we kind of figured out what did work. And then go ahead and do the next one. One of the big things that when you're going from milling to printing that really matters is that box. So whether you're checking the drill compensation box or not is going to have a huge impact on whether or not you get, possibly a loose fitting crown. Even though all of our settings may be fine as far as our cement gaps, this drill compensation can really matter, because if that's checked, it's telling the computer that it needs to account for that path for the mill, as well as whether or not it's going to need that spacer or the diameter of that tool. All right, and so that's the same thing when that's unchecked. Basically, you'll notice that the coping that's generated is so much closer and doesn't have that big reservoir on the tip, and that's just because we're not worried about whether or not we're compensating for the drill. And the nice thing about that is we tend to get really nice fits with our prints just straight out of the printer. So really nice to be able to do that. And then night guards. So night guards, obviously, there are a few things that can really impact how well your night guards might print. So one of the main things I worry about is, if you look down near the bottom, the offset from the teeth to the splints. That's going to basically just be a gap of air between that model and the night guard itself. So the more space you're giving that, the looser they tend to fit. I found that especially with soft night guards, it's a big problem, and that can really cause these things to not really have any retention. The drill diameter is also obviously something I turn down because I'm printing these. So if your normal default settings are popping those up higher, you may want to take care of that and adjust your fit based on those two are the main ones that I mess with. And then models, we do, as Kelly said, we print a large majority of our models. We don't pour. And one of the big things that has been a shift and a desire was trying to figure out, hey, when we're doing these models, how do we design the model to where that's going to actually give us a successful fit from the contour side of that. And so go ahead. There we go. So a couple of the main settings that I worry about when I am printing the models is in that model designer, I always try to make sure that I ditch and trim that model. So that on that box on the left, the blue box that's checked, I always make sure that's checked, because that's going to give me a nice ditch around it on an anterior case like this. That can be pretty important, just because I want to make sure that I'm able to seat the bridge. And if I've got any sort of ponic pressure from a ponic, then I need to, by clicking on this, it will go ahead and hollow out that model to kind of receive that ponic and already have a nice fit. And so this will really help to create a lot less work when you are doing your work on that. So on the other box, on the other side, I always make sure that I hollow out my model. I like to have, I don't want to waste a ton of resin. And so by checking those two boxes early on when you first open up the case, that can really help give you some nice models that once they come out, they're just ready to work on. And one of the big questions I get is, well, what about removable dies? I've for years have worked on trying to perfect that process of creating removable dies on these models. And one of the things that I found is that whether, depending on the manufacturer's resin, the printer, and even just multiple printers within one location, like there can be such variations. I've never really had high success with kind of trying to produce models where I can just pop dies in and out and they're nice and stable. So the biggest thing that I've always found is like they're either just a little too tight or a little too snug, or on a case like this, one or two of the dies might have been a little snug and all the others were loose. And so I just personally have found that it makes more sense to print a solid model that's hollow and ditch and around the margins and the tissue, and then print an extra set of dies. Because everything that I do in the lab is, on these kind of cases especially, is going to go onto a solid model before it leaves anyway. So I've actually just found it easier to produce this, and these are so highly accurate that, I mean, doctors just do not have issues with seating. They fit the dies in these models just like they're going to in the mouth. It's extremely accurate. And honestly, I like it better than any poured model. So a very good way to do those. All right, so just real quickly, a few things with Exocad, a few settings that I've noticed can impact my prints. Right, Exocad does a great job of giving you some nice visuals. So if you're creating crown bottoms, basically, you know, that green area that represents kind of where we don't put any die spacer when we used to paint on the old school die spacer. And that's going to be the amount of, you know, contact between your material and your crown. And that's where a lot of its snugness of fit and just ability not to wobble or have any sort of looseness. And so I try to keep that pretty far down. I extend that zone typically about 1.5 millimeters up. And then I'll usually give it a little bit of a gap. So, you know, 0.03. That usually gives me a good enough fit that it's not loose, but not too much. And then obviously when you're doing the crown bottoms, creating those borders, one of the things when we mill that we always have to kind of pay attention to is making sure that we don't have an unprotected margin, because those, you know, the burrs can sometimes chip those up depending on just how thin they are. When you've got a nice shoulder, that's usually not a problem, but when you don't, printing is a nice way to completely avoid it. And you really don't have to worry about all that extra finishing, like say on zirconia. And then, you know, with the number 5 on this box, that below margin, when we milled, we used to always kind of extend that a little bit, and it would help the mill, and just to make sure that if there was any sort of little chatter or anything in a burr, it wouldn't give us that chipping. With printing, you just don't really even have to worry about that. So I keep that turned down to a minimum. So, all right, and then, you know, with bite splints, you know, you have the ability to actually go in there and kind of preset all that stuff, so you don't have to worry about on each one. And so that's another nice thing but you can kind of go ahead and dictate everything right then and there. I try to keep my block out angle at around 0, but I usually rely on other settings to get that. All right, so designing for like a bite splint bottom, the just like with 3Shape, the main things are just making sure that your offset is going to give you a good fit. Again, especially with the soft night guards. If you're printing those, because they're so much more flexible, they'll pop off a lot easier if you don't have some engagement of the undercut. And then if you look down at where it says smoothing, that one, make sure your default isn't turned up too high, again, especially on these soft night guards, because you want to engage. It's going to basically, the higher that number is, it's going to literally smooth the intaglio surface of your night guard, which can round off some of these little peaks that might be engaging your undercut. So all these settings with night guards especially, they will really make a difference on your fit. And we struggled early on to kind of figure out what settings were going to give us the best. So, all right, so quickly I'm going to run through just creating some successful STL files. You know, what are STL files? Those are the files that we need to be able to generate from our design software that the printers can see and recognize and then print. So it's real important that what we're giving the printer is good information. All right, and one of the things that I think is real important to remember is when we're printing or milling or whatever it is that we do, and as lab techs, we all kind of know this, preps are as unique as fingerprints. You really can't just say, hey, these are the average settings for my spacers when I'm printing. So I'm just going to use these on all the crowns. It just doesn't work that way. If you were trying to print something to go over those abutments and you had your normal average spacers, it's probably going to swivel and not even have any sort of retention and not be a very snug fit. And if you were, conversely, if you were worried about, you know, trying to print these over these preps, they're a little bit compromised. And if I had a very snug fit and my spacers were turned down, I might not be able to get those to seat. And so just bear in mind, as you're generating these copings, all those settings that we brushed through real quick, they're going to change from case to case. And don't be afraid to change those, because that's why all those controls are there. but you need to make sure that you don't get too hung up on one size fits all. And then we all know the challenges in scanning. I mean, we don't get good scans, we know we're in trouble. You know, garbage in, garbage out. It's not going to really be something that we can even hardly design on. And one of the biggest things that I see when it comes to scans is this is like a everyday, all day thing. You know, the scan on the right, you look at it in color, which is more what the doctor is seeing when they're doing their scans, and they say, "Hey, I can see those margins. That looks really good." And they'll send that off to me, and then I will turn on the Medusa feature, which, you know, turns it to stone. And when I start looking at that, then what I realize is, oh, that margin all the way on number 4 on the distal is covered up by tissue. And you don't necessarily see that in the color picture. And so with cases like that, you're going to have a really hard time trying to get a good print. And it won't be your printer, it's going to be the software. So it's going to be that scan that just wasn't very good. Obviously, another thing with scans is making sure that we have room. If I try to print something, especially printing something on a crown where I've got less than 0.5 millimeter of clearance, nothing I print is going to hold up. It's most likely going to fail. So we need to make sure that, you know, you're able to get those models interdigitated as best you can so that you can see just how much clearance you have. And then with night guards, this was a case that Kelly and I found funny because the doctor sent back the case and told us, "Hey, you didn't get enough coverage on this night guard past the second molars." And we literally sent him the picture and showed him that, you know, well, in your model that we didn't actually have the second molars. His impression didn't actually pick that up. And so if you don't have all that information, then obviously you can't do anything with that, at least not what they're going to want you to. So all these little factors can just really add up. So, and then I see this, I'm sure everybody sees a ton of this, where we just have incomplete data. And so if, you know, if that doctor wants a broad contact and I can't do anything with something like that, you're guessing because the software is going to close it up and it's going to just kind of guess at what that material, you know, where that should join. And it's just going to kind of bridge it. So those kind of things can, you know, really make it difficult for us to create a good file and give it something that's going to just drop in the mouth for the patient. All right, so, you know, basically the big come away from that is we want to make sure that whatever we're feeding to our printer and the STLs that we generate are going to be successful. And we can't do that if we don't understand our software and have the right information that we need. And so no printer, no matter how good the printer is, can do anything with a bad scan or a bad design. So, all right.
All right, thanks, Jimmy. So for those of you who are venturing into looking at printing, what we want to do is really kind of just showcase some of the things that you should look for or things that you should be thinking about as you're getting ready to implement. Because the question is, when failures come, where do they come from? Because there is a journey in trying to implement these things, and you will have challenges. Change is hard, and we will have failures. But what I want to do is make sure that you guys are asking yourselves the right questions and looking at the right things and how can I prevent this? And so for us as a lab, we struggled with our accuracies in the beginning. We struggled with removable dies. We struggled with implant models. We chose in the beginning of our journey to start with closed system printers. And so we didn't always like the materials that were available to us. One of my largest complaints from our technicians were, "Oh, I can't draw on the model. I can't draw my anterior line angles." Or, "We can draw on it, but we can't steam it off. And now this model looks like crap that we're sending back to the doctor that we're actually going to charge him for." And as we kind of started to work through our inaccuracies, one of the biggest things we could never figure out in the beginning was how to properly get DIMs to fit into our implant models. We had a 5-figure annual outsource bill, and it was just something that we wanted to bring in-house. And with the money that we were spending on outsourcing, we thought we need to invest in good printers. We need to invest in printers that are accurate and who can help us solve this problem and bring the quality in-house. So for resin selections for us, it's so important that you guys realize that resins are very different from manufacturer to manufacturer and even bottle to bottle in terms of that some manufacturers make two different model resins and they're different for a reason. And so I showcased two pictures here. The top one is a Straumann resin. It's probably one of the most fun resin model colors out there that we like to use sometimes just for fun. But then the bottom one is actually Argon Model Pro Neutral Gray. It is the workhorse of our lab. We really enjoy this resin. Our accuracies and our fits, utilizing our rapid shake printers and utilizing this particular resin, our issues are virtually gone. They slide right in. They're not too tight. They're not too loose. We are very, very happy utilizing the printers and the resins that we have really worked hard to kind of figure out what gives us the best results. And right now, to date, our largest growth area in our lab is implant models. And I think it's because so many doctors want to go digital and so many doctors are happy with what we are producing and word of mouth spreads. Hey, you're trying implants, you're having problems, try our lab. So it's important that you dial in your settings when you're switching resins. So I don't recommend starting with 6 different resins. I recommend starting with 1 so that you can work through it. But it's important to remember that all resins vary greatly in terms of like their tolerance to temperature, mixing times, ease of use. And so if you start with a resin and you're just not getting the results that you're hoping for, I do recommend trying something else. It could just be that that resin is not a good fit for you. Guys, if you haven't printed, it's super important to know that printing is messy. You think milling is messy, printing is 3 times as much. It's super important that you wear PPE when dealing with resins. They are caustic. We don't want to be touching uncured resin. Once it's cured, you're free to handle it with bare hands, but up until then, you need to make sure you're wearing PPE. And guys, it is so important that to keep things clean. These are actually just Googled pictures that I pulled off the internet of resin spills or super dirty print screens. But those streaks matter. They will affect your accuracies. They will affect your print clarity. And it is imperative that if you have one clean place in your lab, it is the print screen of your printer. And the other thing I would tell you in your printing journey is if you make a mistake, if you have a resin spill, if you drop something, just disclose it. It helps people like me help people like you a whole lot faster rather than chasing down a rabbit hole. So consistency, I talked about how there's a learning material with each new curve, but I also think it's important that you look at your own processes. How are you doing things? If something goes wrong, did you do something different? You know, it was really interesting. We recently had a case where a doctor called me up and said, Kelly, this is so dark. And I'm like, well, it's the lightest shade I have in a 3D printed. I'm sorry, it's not light enough because we're in Dallas, guys. People like BL1, they like OM1, they want white teeth. And so I was thinking that we just didn't get it light enough for them. But really what happened was when I went back and looked at the reservoir that we had printed out of and looked through our files, we actually had printed it straight out of a B1 instead of an OM3. And so I wanted to blame the material or just think the doctor didn't have something, but really it came into our process changed. We mislabeled a reservoir. And so things to just think about. And then proper training of staff is absolutely imperative. Guys, most accidents that we see is when someone's on vacation and someone is covering, and that person may have not been properly trained and accidentally poured resin into the printer instead of removing the vat and they spill. It's just things like that that we want to try and help you guys prevent. And so we want to make sure that you guys are properly trained and that you feel comfortable in using your materials. In terms of accuracy, while yes, it is important to have the right settings, so much of your accuracy actually comes in your post-processing area. So it's super important that you guys, when you are looking at buying a new resin, that you are reviewing the IFU for that resin. Those IFUs can tell you tidbits about how to mix something, how to post-process it. This is an example that I pulled from a Keystone IFU. And basically, it just tells you that in order to achieve consistency of your resin and to prevent bubbles, you need to mix it and then let it sit for an hour. And that's actually something that's really important because sometimes I'll have customers who call up and say, oh, I'm having this problem. And we'll go through the IFU and we'll say, hey, did you do this? Like, no, I didn't. I said, I think this is where your problem will be. And I think it's important to review them as well, because if you're going to buy something, make sure it's something you really want to do. Some of them have more complicated instructions than others, and some have better IFUs than others. But I think it's a good place to start when you don't know what you're doing. The other thing is you don't want to cut corners on your IPA. Guys, use your 99%. It will make a world of difference in your cleaning. And when you don't properly remove all the resin from your printed application, you will have fit and inaccuracies. So remember that those are important things to have. And toothbrushes and micro brushes are your friends. And quite frankly, they are an absolute necessity when you're doing your post-processing. When you're incorporating feedback and printing into your lab, it's important that you get feedback from your technicians, because really and truly printing is constantly evolving. Jimmy mentioned how I'm always printing, always doing something that's different and trying to get feedback from people. And I think that when we are squeaky as technicians, when we are asking our resin manufacturers, when we're asking our printing manufacturers what we need, and we're telling them this is not working or this is what we want, they're listening and they're evolving and they're trying to meet our needs, and things are only getting better. So just don't be satisfied with it's just okay. Ask yourself what can be better? Where's our process failing? What can we do better within our own lab in the 3D printing realm? So one of the final things that I like to talk about is support. When you guys are looking at buying a 3D printer, I think support is imperative. I think we feel that way about all of the equipment we bring into our lab, because when we're down, we're not making money and we're not serving our customers, and that is stressful. And so one of the things Rapid Shape is really great about is their support. And so I thought I would just showcase a little bit about the support that we provide for people who decide to come on to our Rapid Shape family. We have Care Plus that's included for the first year when you purchase your printer, and you have the option to extend it up to 5 years. That will guarantee that your printer will always be printing and always help the help you need when you want it. If you're new to printing, something that's unique is that we come with a 90-day coach, which is what I am. I'm a digital workflow specialist, and I'm here to help ensure that your 3D printing journey is successful. So I'm with you for the first 3 months, checking in with you, making sure that you understand what's going on. I'm kind of at your beck and call to help continue training you, your staff, covering different workflows as you get comfortable with models, you want to bring on crowns or splints. We're going to work together to make sure that you have all of the information and help that you need. What's nice is that not only does Rapid Shape have support worldwide, but here in the US, we have a team here that's available to help you when you need it. You don't have to wait to the next day. And then we also have a customer portal that actually is incredibly helpful in terms of not only like information and articles, but I love that it actually gives us a lot of information about our printers. It helps keep track of our reservoirs, which Julia referred to earlier, is really kind of one of the crown jewels about these printers. They're glass reservoirs. They're incredibly durable. If you've ever seen printing vats or reservoirs that are very, very thin and easily punctured just by a stray support, these are not going to have that problem at all. And we have the ability to track them. They're long lasting, and I really enjoy working with those. And if your printer goes down, we're going to swap it out. You're not going to be down for very long, and we're going to make sure that we can keep you printing. So guys, we appreciate the time that you have given us in terms of just getting to talk to you a little bit about software design and about printing and what you might need to bring it into your facility. And so I always say, if you look at someone's camera roll, it tells you a lot about that person. And if you were to look at mine and look at Jimmy's, number one thing is it's pictures of our kids. We have 2 little ones that we absolutely love taking pictures of. But then the second thing is teeth. And I would say it even rivals the kids. So I just thought I'd put together a fun little video of all the 3D printing pictures that I've had over the last couple of weeks and what I've been doing in the 3D printing world. And hopefully you'll see something that intrigues you that you would want to do within your lab. Thanks, guys.
Thank you so much, Kelly. I think this was a very good introduction to what to focus on with printing. And thank you so much, Jimmy, because I think the settings are really a key component of achieving successful print jobs with that. So I think we cannot underestimate the importance of proper scanning and good design in order to actually get a good print. I would like to tell everyone now that's online, guys, please add your questions so we can go into the Q&A session. We will take some time here not to go through this. Appreciate Kelly's beautiful slideshow here because she's really showing a great variety. I see a lot of pictures with the D50 running here. That's, I'm assuming it's a 20. Yeah. We do have some questions, and I love the guys from South Africa are very active, so I really appreciate that. one of the questions from Marius was, do you service South Africa? And I think Lister, you asked a similar question, whether or not we, who can we approach in Cape Town. So actually, we work in South Africa with MedBay. I'm sure Dave actually referred you here, so very happy to have you guys. We do service through them essentially. So MedBay would be your first point of contact, and Rapid Shape, of course, supports them through our customer service, which is based out of Germany. But if you have a D50, for example, on-site visit is part of that topic as well. And if you are interested in learning more about Rapid Shape and you want to go into more detail, you have the ability to schedule a demo with our digital workflow specialist team. For the United States, it's these two ladies right here, Kelly Fincher and Liz Pastrana. Liz, you're online as well, so hi. These two would help you get to know the equipment. You actually have the opportunity to request a sample as well. So if you select that, then you can see, what Rapid Shape is all about. Yeah, thank you guys for joining us. I'm kind of looking for a few more questions. I hope we're getting some in, but it looks like we're quite busy. So it feels like we have most questions answered. That's pretty awesome. Yeah. Well, Jimmy, Kelly, I think I have a question for you guys, and this is maybe a bit more chit chat. But I didn't introduce you in the beginning that you're a married couple, but I think your names give it away. What do you like most about working together?
Oh, that's a good one. I don't know. Most people are
Threw you
asking,
off.
how do you do it? And I would say we do it quite well.
Yeah.
I think it helps that Jimmy's my best friend. And so we just really enjoy hanging out together and putting up with each other. We are by no means perfect. And there are days where our employees go, ooh, mom and dad are fighting. And, we're running around being snippy. But overall, I think we just really enjoy working together. We're very much, he's big picture, I'm details. And so we fill in the spots where the other is deficient. And so he pushes me because I am someone who is not a change person. I am like, let's just keep going with this. This is great. And he will be like, nope, we can do it better. Or I've got a new idea. And so then he pulls me in and I'm his implementer and we move forward together. So
That's great.
I really didn't know if I would like working with her at all, to be honest. But yeah, so the thing that I like about working with Kelly is A, she's smart and she likes to learn and she's just good at what she does. But B, she'll listen to me yell at her and then she'll forgive me. So that's one of the best things.
Yeah. Okay, well, I appreciate it. I think that's quite sweet. Yeah, I do think one of the questions I could ask here is definitely about the D50 being quite the, unique printer with the automation system. I think that comes with a lot of benefits, Kelly. I think if you could highlight the benefits a little bit to the group, but maybe also say, okay, what are some things that with the automation systems employed, what do you maybe have to pay attention to ensure that, you're achieving good results consistently?
sure. It's interesting. I think when people in the lab world see the automatic separation, you get excited. It's kind of like the change arm of a mill. Ooh, it can change by itself. Ooh, it can start the next job. But when you really start breaking down what automation can mean for you in your lab, it actually gives you time back, makes you more efficient, allows you to do so much more with that technician that you would lose knocking things off of a plate, having to reclean the plate, having to then start the next job. And so for us, it has allowed us to completely streamline printing when it wasn't streamlined. And I don't think I even realized that until the 50 came in and we really and truly embraced it, because we've learned, while yes, I can fill up a plate and print it and then it will cut it off. What I've also learned is it's my time to come into the model room. I may only have 2 jobs, but I'm going to add it and move on. And then when I come back, yeah, I may have 2 plates worth to nest with the next time, but it makes it so much more efficient that I come in and at certain times during my day, nest what's needed and move out. And so that to me has kind of been priceless. Like one of my other printing technicians that works with me in this room goes, I feel like we got another person working in here because I come in and half of the job that I spent my time doing is done for me. And I think that with bringing in automation, it allows me to really focus on growing more of it without the need to bring in more equipment, because this allows me to step away and do it for me while I'm doing other things. And that's been a really great change for us.
Yeah. Yeah. I think that's quite an important point. We do have a question from Ok. He's asking about our curing system. Can you elaborate a bit on your post-print wash and cure unit? Does it cure with nitrogen? And Kelly, I'll let you talk, but I'll pull up the slide here that shows our wash and cure, at least a desktop version. Yeah,
you do have the ability, if you wanted to connect nitrogen to our cure, you could, but it's not necessary. We actually cure under vacuum. And so it does remove all of the oxygen from the chamber to give you a better, more complete cure. The only time I've ever felt like I've had something under cure within our cure is when I have overcrowded it. Because remember, it's important. If you've overcrowded a cure chamber, then you're blocking the light from giving it the 360 light distribution. And so you'll easily see a section that may be under cured because of that. So something just important to remember, don't overcrowd. And really, we see really good complete cures. I don't know if you've ever worked with a cure unit where something may not feel like, it almost feels a little tacky or it just feels softer. When we're curing under a vacuum, these things are coming out crisp and hard and like what you would expect a 3D application to come out feeling like.
Yeah. Okay. And then he does ask the follow-up question, does nitrogen in post-curing have a valuable role? How do you deal with an uncured layer? I think you answered that with your question, like with your answer there. Do you want to add anything?
We know that nitrogen basically increases our flexural strength, right? And so when we cure in the absence of oxygen and adding in the nitrogen, then we're increasing our flexural strength and the durability of whether we're printing a crown, a night guard, an all-on-X. We're going to see those applications have a better flexural strength.
Mm-hmm. Yeah, I do think this is an interesting question from Andre. He's asking, any comments on patient being allergic towards the monomer? Is it a problem you picked up? Thank you for the question. I think it's a very important one.
Right. Yeah. So it definitely, there are patients out there who do have allergies to 3D printed applications. So it is important that as a lab, we are disclosing that it is 3D printed. And then it is not an allergy I per se have picked up. I also do my due diligence to make sure that I'm wearing proper PPE to not expose myself unnecessarily. I did tell you guys that I was a nurse previously, and I actually was an oncology, a cancer nurse. And so I think following proper protocols, especially with carcinogenic materials, is super important because I've seen the end of that. Sorry, my light goes out. Our print room has automatic lights that turn off. And so just to reduce UV rays. But yes, it's something that is important to disclose that it is 3D printed application so that we can protect people.
Yeah. Just being aware of that is relevant. Yeah, I mean, it looks like we don't have any more questions coming in. So I'm going to give the people who are online 2 more minutes to add any more questions. I will use this for a shameless plug for Rapid Shape, of course. And yeah, I do want to highlight our amazing partners in the resin sphere. We have a ton of different validated materials on various printers for us. So do check that out. Go to our website to see which materials you may want to try out that you haven't. And yeah, get some.
Julia, we got one more question from Mark.
Perfect.
So he wanted to know what we do when transferring from printer to the wash unit, dental cloth, etc. So Mark, what's unique about our wash system is it actually does dry. And so what I love is I call it the swamp. We don't have a swamp in our wash. It actually has bottles that pumps in the IPA and then pumps it back out. So you're never going to accidentally leave a 3D printed application in IPA for too long. And if you've done any printing, that is seriously the most frustrating thing. You get distracted, you walk away, you forget, and now you're starting all over because you compromised your print. So it drains it out and it dries it off. I would tell you, if I pulled it out immediately when the wash stops, it may be slightly moist. I may hit it with a little bit of compressed air. I don't think you can see my cord, but I have compressed air right here in the printing room. If I walk away and come back in like 10 or 15 minutes, that application is completely dry. I do nothing to it. I just put it straight into the cure.
Yeah. Okay, cool. Thank you, Kelly. I think that was a good question. So if there are no more questions, then let me jump back to our beautiful slide here of Kelly and our digital workflow specialist, Liz. If you guys want to book a demo, now's your chance. I also put the link in the chat. Feel free to reach out to us at RapidShape. We would love to take the time and go into detail. What you can do when you go book a demo is you select the 3D printer you think is most suitable for you in terms of capacity, and then you can talk to our team and find out more about it. Of course, they will help you find the right solution for you. As you've seen, RapidShape does have from desktop equipment all the way to standalone units. So if you are a smaller lab or a really high volume producing lab, RapidShape does have a solution for you. And thank you so much, Jimmy and Kelly, for taking the time for being here. Oh, okay. We just got another question in, so we will address it now. Mark, thank you for being so active. We appreciate it. Mark's asking, are you guys printing and pressing Emacs, etc.?
Yes, printing. Well, we're not printing Emacs, but we're definitely printing. I mean, a lot of nano ceramic as far as restorations go. So especially with All on X, what a lot of our Essex retainers. So we'll do a lot of printing as far as teeth go with a nano. What materials are you mostly pressing those with, Kelly, or printing those with?
So probably we mostly use Pactent materials. We do use some Straumann materials, and we use the RS Vivo, which is specific to our RapidShape line as well. So we use several different ones. We have doctors who have preferences where they like one over the other. Some polish better, some glaze better. So really, it just kind of depends on what look works best for you. We do still press. If you're asking about that, we do very little of it these days. As someone who does all the ordering in the lab, I don't order investment very much anymore, but we still have some cases that do require pressing. Sometimes it's just matching an old case that we've done in the past that was pressed, and we want to maintain, the cosmetics of that case. And so we continue on with the same material we've done in years past.
All right.
Yeah, for the most part, I'm only going to press when I cannot mill. So there are some times where a prep is compromised, and the mill just is not going to be able to create a path and give me anything that's going to fit very well. So in those cases, we will still do that. But yeah, Kelly's right. If it's an old case where we did a pressed several years back, then we might need to go with a pressed, because the values can be a little bit different. So typically, the value doesn't quite line up between a pressed or a milled Emacs.
Mm. Okay, well, actually, I was going to say, what kind of workflow would you guys like to see next on the RapidShape webinar series, essentially? So we are going to continue this webinar series throughout the next couple of months. We are actually now going to really focus on different workflows and give tools and step-by-step tips for achieving best results across a variety of different workflows. So guys, if you do have a specific request, you can always send us an email to our team. If you want to reach me to tell me, hey, Julia, please organize this webinar, then go to marketing@rapidshape.de. I'm putting that in the chat as well. And then if you want to learn more about our solutions, feel free to go to our website or to book a demo right away with Liz, Kelly, or our other digital workflow specialists from across the world. Then I'm going to say thank you so much, Kelly and Jimmy, for your time and your skills. And thank you for sharing. Really appreciate it. We're looking forward to seeing you next time. I'm sure there will be. And yeah, thank you, everyone. Enjoy the rest of your day, the rest of your evening. Not sure where everyone's coming from, so really appreciate that. And thank you all for being here. Appreciate your time. And yeah, see you next time.
Everyone.
Go.